Hello, we are Miss Morley's Chemistry 2 class coming to you from Western Oklahoma State College. We're going to show you today some cool little concepts and things you can practice with some household items you have laying around. First, let me introduce myself. My name's Trevor. I'm a mechanical engineering major.
My name is Alexia. I'm a biology major.
I'm Jessica, and I'm a biology major.
I'm Ryan, and I'm an electrical engineering major.
I'm Patrick, and I'm a physical engineering major.
All right, and today we are going to show you how to make a light light up, making your own battery from lemons and a couple other things that we'll tell you about.
But first we have some safety features. One, whenever you're doing an experiment, you have to have your hair pulled up, and you have to be in clothes that you really don't want to get dirty or messy. And we're working with sharp nails and a knife, so you want to have a parent supervision while you're doing it, and let the parent, if you're a small child, let the parent handle the knife and the cutting of the lemons. And that's pretty much all the safety features.
First, we got to understand what a battery is and how it works. A battery stores and turns chemical energy into electrical energy. In the lemon battery, there's an electrochemical reaction when it is completed with the circuit. The zinc will have a negative charge, while the copper penny will have a positive charge. In the lemon, there's a citric acid that has electrolytes, which conducts electricity.
All right, and one of the first steps you want to do is you want to grab your lemon. You first want to juice it up, roll it up, make sure you get those juices nice and flowing. And then what you want to do, now this is where the parent comes involved, is you want to get your knife. What you want to do is you want to make a nice little slit, and then what you do is you take your penny from 1962 to 1982, and then you want to place it in the lemon nice and firm. And next.
And then you just put a nail in on the opposite side of the lemon and push it down so it's incorporated in the juice.
Okay. So now that we've got these all hooked up in series, I'm going to connect the last one to the light bulb. And once we get the lights off in the room, Jessica is going to hit the switch and we'll see it come to light. All right.
You want to turn the lights back on?
Yep. Now basically what's happening is we have electrons in here that's going from the penny to the nail, and then it's going to complete a circuit. Now since we have 4 lemons here, that's going to produce a certain amount of volts and amps. Now that volts and amps is flowing through these wires and going all the way to this light, producing light obviously. And that's completing the circuit. Now to pretty much recap what we did is we took lemons and we were able to make them power a light bulb. Pretty simple.
So why do lemons work? So lemons contain citric acid in the lemon juice that helps the electrolytes flow. But what are electrolytes? Electrolytes are any liquid that produce ions, like Gatorade or ocean water.
Okay.
Okay, and then how we set it up is you have the copper penny and then the nail. You want to kind of take the sandpaper and strip the nail of any dirt that you have on it. And you'll stick one end inside of the lemon and then the nail on the other side, and you can connect 4 of them, or you can connect as many as you want. The more lemons, the more power of the battery. And then you'll connect it to something. We used a light as a demonstration, but you can connect anything that's pretty much battery powered. And then we used a switch, but in order to connect them, we used alligator clips with wires connected. And there's a demonstration right here of how to connect it.
And we did want to touch on the 3 different types of electricity. We have stuff that comes from the wall outlet, which is AC, and that's made by big power stations powered by nuclear, solar, wind, or coal. We have static electricity, which is rubbing your feet on the floor, touching a doorknob, something as small as that up to lightning bolts coming from clouds smashing into each other. So what we really looked at today were batteries just like you'd have in your video game console controllers, remote controls, any other small toys that might take these size batteries. So basically we saw a chemical reaction, the same you would inside a battery. We hope you enjoyed our demonstration today. We want you to remember to stay in school, listen to your science teacher, and science is cool.